Hi everyone, let's go over LeetCode number 896, monotonic array. First, let's understand the problem. We're giving an input array consisting of integers, and the output is a Boolean value, either true or false, indicating whether or not the input array is monotone increasing or monotone decreasing. So what make an array monotonic? Let's look at some example. Now look at the first array. When we loop through this array, notice that the numbers coming after the previous number is either greater than the previous number or equal to the previous number. For example, here 2 is greater than 1, then moving to the third position, then 2 is equal to 2, but not less than. Now we have 3, which is greater than 2. So in this array, the numbers are constantly increasing. So this means that this array is monotone increasing. How about this array? Now when we go through this array, the numbers coming after the previous numbers is either less than the previous number or equal to the previous number. Here, 5 is less than 6, 4 is less than 5, and 4 is equal to 4, but not greater. So in this case, the array is monotone decreasing. In the last case, when we loop through this array, then here, let's say we are at 3. 3 is greater than 1. But when we move to this position, 2 is less than 3. So this array is increasing and then decreasing. So it's not constantly increasing or not constantly decreasing. So in this case, this array is neither monotone increasing nor monotone decreasing. Now, how can we solve this problem? The first approach is intuitive. We can loop through the array, comparing each number to its previous number. In the case of a monotone increasing array, then each number will be greater than or equal to their previous number. In the case of a monotone decreasing array, then each number will be less than or equal to its previous number. But doing so is inefficient because we may have to loop through the array twice. Can we do better? Can we loop through the array just once? Yes, we can. How can we do that? So an array is either monotone increasing or monotone decreasing. It cannot be both monotone increasing and monotone decreasing. Now we can have two variables. One is increasing, one is decreasing to keep track of the condition of the array. We can set both of these to true, and because the array cannot be both increasing and decreasing, then at the end, one of these will be false, the other will be true, and vice versa. Or in the case that the array is neither monotone increasing nor monotone decreasing, then both of the conditions will be false, and the final answer will be false. Let's go over this array as an example. Now let's loop through this array. 1 to 2, we have 2 greater than 1. So the condition of increasing is true. Decreasing is false. Moving on from 2 to 2, they're equal to each other. So increasing is still true. 2 to 3, now 3 is greater than 2. So increasing is true. The final answer is true for this case. This array is monotone increasing. How about this example? Again, we loop through the array. Moving on from 6 to 5, 5 is less than 6. So increasing is false. Decreasing is true. 5 to 4, 4 is less than 5. So still decreasing. 4 and 4 are equal to each other, still decreasing. So final answer for this case is true. This array is monotone decreasing. Now let's move on to the next example. In this case, going from 1 to 3, 3 is greater than 1. So increasing is true and decreasing is false. From 3 to 2, 2 is less than 3. So increasing is false. But do we go back and set decreasing back to true in this case? The answer is no. So for the array to be monotone increasing or decreasing, all the numbers have to be constantly increasing or constantly decreasing. But in this case, they're not constantly increasing or decreasing. In this position, even though from 3 to 2 is decreasing, but in this position, from 1 to 3, the numbers were increasing. So we cannot go back and set decreasing to true. So because both of the conditions are false, then our final answer will be false. This array is neither monotone increasing nor monotone decreasing. Let's talk about time complexity and space complexity of this approach. In terms of time complexity, it will be O of n, where n is the length of the array because we loop through the array once. For space complexity, our output is we only need to keep track of the condition, the Boolean of increasing and decreasing. So the space complexity would be O of 1. All right, let's jump to the code when our memory about this approach is still fresh. Let's create two variables, increase and decrease. Set them both to true. Now we want to loop through the array, which is num, and compare the numbers. First case, if num I is less than num I plus 1, then I have to adjust the range as well. So len num minus 1 in this case. Then if num I is less than num I plus 1, that means increase is true. So we set decrease to false. In the opposite case, we would have increase is false. And the last thing that we need to do is return increase or decrease. All right, let's run the code. Perfect. And submit. All right, it works. There is another approach which is not intuitive like the previous approach, but this is an interesting one to know. Let's add a little tweak to the previous logic. Instead of going through the entire array, comparing each number to its previous number, we can memorize the comparison result ahead of time. How can we do that? We can have the two comparison. Bear with me, it will make sense when we go through the example. In this example, let's compare 1 and 2. Is 1 greater than 2? The answer is no. So it is false here. And the values for false is minus 1. 1 is less than 2? Yes, the answer is yes. So this comparison over here is true. And the values for true is 0. Let's combine these two numbers. Let's do -1 minus 0. The answer is minus 1. Moving on. 2 compared to 2. Is 2 greater than 2? The answer is no. So here we have false, negative. Is 2 less than 2? The answer is also no. So this is false. And the numeric values for false is -1. So -1 minus -1, let's combine these two, will be -1 plus 1, which is 0. So if the values are equal to each other, the sum of the comparison would be 0. Let's compare 2 to 3. So is 2 greater than 3? The answer is no. 2 less than 3? Yes. So we have here false and here it's true. So -1 and 1. So same as this condition. Combining these two comparisons, we have -1. So we see a consistent stream of comparison. In this case, if we see -1, -1, the consistent in the comparison, that means that this array is monotone increasing. If we see a consistency in the stream of comparison. All right, let's go over another example. Let's go over this example. In this example, we do the same comparison. Let's compare 6 to 5. Is 6 greater than 5? The answer is yes. So here we have true or 0 for the values. And here would be false. And if it's false, the value is -1. Let's combine these values for the comparison. We have 0 plus 1, which is 1. Now 5 compared to 4. Is 5 greater than 4? The answer is yes. So same here. We have true and we have false for the comparison. So it will be the same situation here. Now we're seeing a consistency in the stream of comparison. Now the final would be 4 and 4. So is 4 greater than 4? The answer is no. Is 4 less than 4? The answer is also no. And we have false, false, -1, -1. And the sum of these will be 0. So now we see a consistency in the stream of comparison in this case as well. So in this case, the array is monotone decreasing. All right, how about this case? In this case, we would do the same comparison. 1 compared to 3. Is 1 greater than 3? The answer is no. So we have false over here. We have true over here. We have -1 as the sum of this comparison. Now 3 to 2. Is 3 greater than 2? The answer is yes. So if it's yes, we have true over here for this comparison, and we have false over here for this comparison. We have 0, and we have -1. All right. The sum of this comparison is 1. No. We go from -1 to 1. So we do not have a consistency in the stream of comparison over here. So that means that these numbers are not constantly increasing or decreasing because there's no consistency over here for the comparison. So that's why this array is neither monotone increasing nor monotone increasing. So the final answer of this would be of this case would be false. All right. Let's go over time complexity of this approach and space complexity of this approach. Just like the previous approach, we also go through the whole array. So time complexity would be O(n) when n is the length of the array. Space complexity, also we keep track of truth and false. So it will be O(1). Alright, let's jump to the code. First, let's create a variable to store the comparison result. Let's call it store and set the values to 0. Now, look through the array, just like we did with the previous approach. Here is when we would add the tweak into the logic. So we would want to keep the values of the current comparison. How do we do that? We can create another variable to store the current values of the comparison and have the two comparison in here. First one, we would want to check if, let's say, number I is greater than number I plus 1 or not. And in the other side, we have the opposite case, which is number I is less than number I plus 1 or not. Then we will combine the values of the two comparison. And the order of these comparison would not matter as long as we're being consistent. As long as we see a consistency in the comparison values at the end, that does always matter. Now, if we have compare values, then we would want to check if the current values is consistent with the previous values or not. So in order to do that, we would do the comparison, the current comparison values with the previous comparison values. And we also just worry about the values -1 or 1. We don't want to consider the value of 0 because if it's 0, and it means that we're having the two numbers that are equal to each other. So here we would want to ignore the number of 0, the value of 0. In this case, if we have an inconsistency between the values of the comparison, then right away we can return false. And we want to set the current values. We want to set store to the current values and keep going. The last thing that we need to do is return the final values to true. So if it's not false, if this condition does not happen, then the answer is true. There's another thing that I forgot to mention is that this approach is a little more efficient than the previous approach in some cases, because right when we find an inconsistency in the comparison value stream, then we can right away return false instead of looping through the whole length of the array until returning the final values. So check this code to see if it works. All right, and submit. All right, great, that works. That's it for this video. I hope this is helpful and happy coding.